Today, my presentation is about opening your eyes, opening them wide. I'll be doing that right here on this stage. As they already said, I'm Kirill Kruglov, a researcher and developer on the Kaspersky ICS CERT team. This is important because our team handles industrial safety for industrial systems, including data collection and analysis, conducting research vulnerabilities, searching for them, and reporting to vendors all the necessary information to get patches as soon as possible. Today we'll be talking about statistics in the threat landscape. As I already said, there are people who are right when looking towards life in the future. They say, I always keep my eyes wide open because something terrible might happen and I need to be fully prepared for attacks from all sides. Let's start with the fact that we have a huge amount of data from all the industrial systems around the world. Systems whose users have a confirmed KSN agreement and voluntarily share with us anonymous data about the threats our products detect and prevent. We're in about 160 countries, about the top 10 in these industries. They can be broken down further, but we'll start from the top. We know 4 sources of threats and about 10 types of threats. These are generalized groups that, as you'll see later, allow us to work with statistics, because at a very low level, at the level of individual files and detectors, it's very difficult to make comparisons of groups and provide statistical analysis. Let's look at the simplest graph, quarterly data from all over the world. The percentages are computers. From all the computers we know that reported a threat that was blocked according to the rules, the notice received by the user. These are real threats, real detects. It could be some kind of phishing site or email. It could be Trojans. It could be spyware or encryption software on workstations, for example. This is all collected in the big picture and shown in the graph. Overall, we see the trend is declining. There are peaks, but overall, everything is going down as if our life is getting safer and safer. But this is just the general picture, like the average temperature in a hospital. If you look at least at the regional level, these are groups of countries, then it's clear that there really is something declining in those regions that previously showed very high percentages. 38% is a lot. Imagine almost every second computer in an organization, one way or another, in the quarter, had some kind of detect. Not exactly calming news. There are peaks on the chart, and we of course analyze them. We discover new tactics, new techniques, new exploits used all over the world because they affect things like larger groups such as regions. If we look at regions where in principle there's some sideways movement, lateral movement, there are spikes, but overall everything is generally going in the same direction. Let's look at Russia. That's this big spike. This was related to the use of a wide range by attackers, not targeted attacks, but everything in a row exploiting a vulnerability in a web application. And this vulnerability was used in the web application to add malicious code that the user will receive if they follow the link to the site. You visit this site every day, then tomorrow you go there and there's some malicious code that tries to attack your computer and get inside. Countries where we saw the lowest percentage of attacked computers, meaning the most prosperous regions, show the most oscillation. So it's just a matter of time before some regions will be heavily attacked, while others, on the contrary, will decrease, and so they oscillate in an infinite dance. What's interesting is that the first thing I might hear from maybe not you, but someone else employed in cybersecurity and industrial systems, oh, come on, we don't have any servers. We don't have web servers or web applications. There's no internet access. No one goes there. But the truth is that these conglomerates we made by types of threats represent a funnel that salespeople call conversion. So these are like the least dangerous threats, like malicious websites, IP addresses we know are either used in attacks or distribute malware. They're like the first step, the least dangerous. This funnel collapses downwards. So if an attack is successful, it reaches the very bottom and usually ends with encryption software, spyware, or miners. It's all luck. It's a game of roulette that I wouldn't play if I were an employee of some security service or doing cybersecurity at a plant, because this is serious stuff. It's not just a workstation or office computer, as you know. My computer broke. Okay, I get a new one from our support team. Here, if equipment fails, especially how we live today, for example, in Russia or in other regions, you might wait for a very long time. It could be difficult to replace. If you're interested, we have a website where we publish our research for free. There's also statistics there, threat analysis, and so on. More advanced, more in-depth analytics are available on our TP portal, which you can find easily on our official website. Right now, we're talking about the practical use of statistics for cybersecurity goals. I think there are reports, complex research on threats, attacks, different steps, techniques, and tactics are described, procedures, and lots of indicators of compromise. Just take any report or machine-readable file with IOC, load it into your SIEM, and start looking around. You'll probably find some traces of an attack that's already been written about. Statistics are a bit more complicated since there are no indicators. There are several million there easily within a month, and there's no way to upload them to a SIEM system, and in general, no real point. This is an unnecessary overload, which probably won't help anyone except a very few people. On the other hand, the statistics are quite extensive, and the only approach to make it practically applicable is to group this data into clusters, identify their characteristics, and use them in some predictive system or in materials with recommendations on how to increase security specifically in a given region or industry, how to approach it as precisely as possible, the issue of customer safety, which is really the reason we make these solutions. The first thing to start with is, if you ever start thinking about how to use statistics, is that the statistics firstly are based on large numbers, so you don't get any distracting vibrations in small samples. The second most important rule, it is to have data that is well distributed. If the data isn't distributed well, its use is highly questionable. As you can see, we have 4 sources and the data is well distributed. This is a logarithmic scale. This method is used to correct graph shifts left or right, what's called kurtosis. We also have, so here are 9 because 10 just didn't fit. Types of threats, they also have good distribution. The 10th type is viruses, but it's similar to malicious software such as worms. They have slightly different distribution mechanics, but in general they're very close to each other by many criteria, but not for all. Let's imagine some null hypothesis, a question or assumption that we could easily refute and get this refutation in some explicit form. Here I asked a question like, is there a connection between the internet, threats emerging from the internet, and threats from email clients? This is important. A mail client is an application on the host you use to access corporate email. This isn't webmail or a web interface, and it turned out there was no connection. This is for industrial systems. This means that users who use email in the technology segment won't necessarily have internet access. Conversely, users who have internet access won't necessarily have an email client at their station. How can we read what this graph shows? First of all, it's the connection between email clients and the internet. It's also a logarithmic scale. These pale dots are dots grouped by country. That is, one point is one country at a certain period of time. The percentage of computers we see informed us about detects. The purple dots, the bright dots, are those where there is a connection. Since there are very few purple dots and they have the shape of a sphere, the probability that the connection really exists and is real, or it can be traced or can be predicted, is extremely small. So the pictures shows the absence of correlations between 2 threat sources. Let's look further. On the contrary, some hypothesis that was 100% correct, at least empirically. Is it true that malicious documents are delivered into an industrial network on a computer to the industrial network by mail clients? As you can see, the dots lined up in pretty much a straight line. No pale spots are visible. This means the correlation is maximum here. Worms and removable media. All the flash drives everyone's talking about already protected everything they could, but still we see a huge correlation between flash drives and worms distributed through them. There are some minor deviations, but overall, nothing critical. Now for what I was talking about, a slight difference in the viruses we observed from the worms in this statistical model. Viruses that spread via removable media have a much larger tail than worms. It might seem like it's an anomaly, but if you look closely at the data, analyze everything we have, it turns out that there are certain computers where the removable media scanning component is turned off for some reason. So we see the consequence, we see a large number of virus infections at terminal stations, but we also see that some special exceptions are set up for removable disks, or components are turned off, or some other configuration that creates this tail of abnormal blue dots. What's funny is that using statistics, we can identify missing pieces of the puzzle and explain and teach people involved in industrial cybersecurity what they shouldn't do. Disabling protection of removable media won't help protect from viruses and vice versa. Here's something interesting, spyware. The question is, does spyware really come from the internet in the industrial segment? Well, not quite. We see the cloud is spreading, that there's no clear connection between the internet and spyware. Why is that? Because the chain used to deliver spyware from the internet is much longer. Most likely, a script or document flies come from the internet first, then another script emerges that calls another script, which calls something else, and somewhere in there, the spyware is downloaded. Let's take a look at malicious files. We see that from malicious files, meaning Excel, Word, PDF, that's where the malware is delivered to the user. It can either be downloaded some sneaky way so that we don't see that it's from the internet, or it's directly inside these files. As you can see, unlike the internet, here the density of dots is much higher, plus we see two lines. This means that there are two groups of users who, in some different way, these harmful files are used for delivering spyware. Scripts, as I already said, in general, the connection is essentially the same. So we're missing a small piece of the puzzle, some other additional types of threats, and something else that we'll definitely find. We'll analyze these points and identify them, and then we can build a complete chain. As for ransomware, is it true it's delivered using spyware? As we can see, there's nothing here. But these individual purple dots show that there are some countries where the connection is direct and completely linear because they're lined up more or less in one line. There just aren't many of them. This means that such a development of events isn't very common. The scripts are a little more dense and so on. In short, you get the general concept. The main idea is that there's the MITRE matrix that everyone loves and uses. Its tools, procedures, and toolkits, but it lacks a third dimension, a lack of connection between different types of sources, different types of threats. And it's this third dimension we'll build on the basis of our statistics, so we understand how this looped graph is connected to a specific client or for a specific region of the industry. Well, I hope it was at least interesting for you. Thank you very much. That's all. Bye, everyone.